Hi friends, now in this video we are defining some terms: Valency shell, valency electrons, octet rule, valency and oxidation number by simply taking sodium, chlorine, neon and helium as examples. In the first one, valency shell. Valency shell is a shell. It is a final shell. It contains at least one electron. Then it is called valency shell. So, in the first example, sodium. Sodium atomic number is 11. In the sodium atom, in the first orbit or first shell contains 2 electrons. In the second orbit, it contains 8 electrons. That final shell containing 1 electron. That's why the final shell is 3. So the sodium valency shell is 3. Similarly, the chlorine also having 7 electrons in the third shell. It is the final shell of chlorine. That's why the valency shell of chlorine is 3. So here neon. The neon contains 8 electrons in the second shell. That's why the second shell is valency shell for neon. Helium. Helium valency shell is 1. The second definition, valency electrons. Valency electrons nothing but the number of electrons present in the valency shell. Number of electrons present in the valency shell is called valency electrons. The sodium valency shell is third one. In this third shell, only one electron is there. That's why the sodium valency electron is 1. In case of the chlorine, the 7 electrons is present in the third shell. That's why the 7 is valency electrons of chlorine. Verse-wise, the 8 electrons is present in the second shell. So 8 is the valency electrons of neon. Helium valency electrons is 2. The third definition, octet rule. The octet rule, it is explain the stability of an element or atom. According to this rule, an atom contains 8 electrons in the valency shell. Such atoms are stable in nature. Otherwise, those atoms are unstable in nature. According to this rule, that sodium valency electrons is 1. Nothing but only 1 electron is present in the valency shell. That's why it is unstable. The chlorine is having 7 electrons. It is also unstable. But neon is stable because it having 8 electrons in the valency shell. That's why the neon is stable according to octet rule. But here we are remembering one thing, that octet rule is also having some limitation. For example, helium having only 2 electrons present in the valency shell, but helium is stable in nature. But according to the octet rule, only 8 electrons containing atoms in the valency shell are stable in nature, but the helium is stable against to the octet rule. And also xenon having 8 electrons present in the outermost shell, but xenon is unstable in nature because the xenon is formed bonds with other atoms to form a compounds like xenon difluoride, xenon tetrafluoride, xenon hexafluoride, etc. By these examples, we are concluded the octet rule is applicable for only some elements, nothing but the octet rule having some limitations. So the fourth definition is valency. The valency, nothing but it is explained the number of bonds formed by an atom. Here the sodium atom is formed only one bond. That's why the 1 is the valency of sodium. Similarly, chlorine is also formed only one bond. That's why the valency of chlorine is also 1. Neon is stable in nature. That's why it is doesn't react with any other elements or atoms. Therefore, the neon bonding capacity is 0. So valency of neon is 0. Helium is also stable. That's why it is doesn't react with other. There is no bonds formed helium with other atoms. So that's why the valency of helium is also 0. And finally, oxidation numbers. The oxidation numbers nothing but the number of electrons gained by an atom or the number of electrons lost by an atom is called oxidation number. Sodium having 1 electron in the valency shell. So if in case it lost 1 electron, that final shell is 8. electrons. So according to the octet rule, the sodium will become a stable when it lost one electron. That's why to get the stability purpose, sodium will lose one electron, it gain plus one charge. That is the oxidation number of sodium. In case of chlorine, it contains 7 electrons in the valence shell. If in case chlorine gain 1 electron from others, it having 8 electrons in the valence shell. So it will become a stable according to the octet rule. That's why the chlorine gain 1 electron to get a stability. So in this time, the oxidation number of chlorine is minus 1. Here minus indicates gaining of electron, plus indicates losing of electron. But neon and helium is almost stable in nature. That's why it doesn't gain or doesn't lose electrons. So the neon, helium oxidation numbers are 0. So by depending upon the octet rule, we are giving some valencies and oxidation numbers of elements. But we are remembering one thing here, that octet rule is having some limitations. So elements: hydrogen, lithium, sodium, potassium. So these are the all elements having valency is 1. Nothing but these are the all elements formed only one bond by losing of 1 electrons. That's why the oxidation number of these elements are plus 1. Beryllium, magnesium, calcium. These are the elements valency is 2. Nothing but these are the elements formed 2 bonds by losing of 2 electrons. Boron, aluminum. Valency is 3. These are elements forming 3 bonds, triple bonds, by losing of 3 electrons. In case of carbon, silicon, valency is 4. Nitrogen, valency is 3. Oxygen, valency is 2. And these are the halogen, valency is 1. So in this table, we are giving elements classified as a groups and correspondent valencies and oxidation numbers. That valency and oxidation numbers are given these elements by depending upon octet rule.